Hi, this is Bob Pryor. I'm talking to you today about graphing the secant and cosecant functions. We're going to start by talking about the reciprocal functions in general. F of x equals 1 over x. That's called the reciprocal function. Notice it says here that the reciprocal of a large number is a small number, and the reciprocal of a small number is a large number. I think that makes sense. Let's go ahead and identify some points for this function by choosing some x values. We'll start with x equals 3. So f of 3 is 1 over 3, 1/3. That makes sense, because 1/3, of course, is the reciprocal of 3. So we have the ordered pair 3, 1/3. And when x is 2, the function is 1 over 2, 1/2. We get the point 2, 1/2. When x is 1, the reciprocal is 1, 1/1. What happens when the x value is smaller than 1, like 1/2? Well, the reciprocal of 1/2 is 2 over 1 is 2. So we get the ordered pair 1/2, 2. And if x is 1/4, well, the y value is 4, 1/4, 4. We could even get carried away and say, well, what if it's 1/10? The reciprocal of 1/10 is 10. And if it's 1/100th, even smaller still, well, gosh, the reciprocal is going to be 100, a very large number, comparatively speaking. Well, we won't graph those last two, but let's graph the other ones that we have. 3 1/3, 2 1/2, the point 1, 1/2, 2, and 1/4, 4. Sure, what the heck, 1/5 and 5. We know that they're reciprocals. And we'll draw the graph, and we'll put arrowheads on each side. We can do the same thing when x is negative. Like when x is -3, well, f of -3 is 1 over -3 is -1/3. In other words, the reciprocal of a negative number is negative. And we can do that for -2 and -1. What we generate are quadrant 3 values, and you can see them plotted here in quadrant 3. And of course, then we draw the graph through them. Now, what you'll notice is that on the right side, the graph goes straight on up, remember, up to 100, and down to probably -100 on the left side. And the line that's on the y-axis that separates those two is called a vertical asymptote. A vertical asymptote is a line that acts as a guideline for a graph that continues indefinitely upward or downward. A graph never touches or crosses a vertical asymptote at any point. Now, a vertical asymptote does not need to be on the y-axis. For example, in this function, f of x equals 1 over x minus 1, the denominator x minus 1 cannot be 0. And that means when we solve, x cannot equal 1. What that also means is that's where we have a vertical asymptote at x equals 1, and you can see I've drawn it here. So here are some of the points that are actually on this curve, and as you can see, the graph follows, on the right side, follows upward along the asymptote, and on the left side follows downward along the asymptote. But we were just talking about those so we could talk about this, the secant function and the cosecant function. Let's start with the cosecant function. First of all, what I'm going to do is I'm going to draw a y-axis and an x-axis. And what we have here are secant values from 0 to 2 pi. Notice that secant is sometimes undefined, and that actually causes us to have an asymptote, a vertical asymptote. And if I connect all those values, this is the shape of the graph of f of x equals cosecant x. Here's what it looks like in the xy plane. Remember the secant values, 1, 2 radical 3 over 3, which is approximately 1.15, square root of 2, which is approximately 1.41, and 2. Those are common values for cosecant function. Now you can see there at pi over 2, the graph is 1, and that's a minimum. And at 3 pi over 2, on the negative side, we have -1, but that's a maximum. That's the highest point for the negative values. Next thing to note is that the portion between consecutive asymptotes is called a branch. Here we see 2 full branches of cosecant. Let's do the same thing with the secant function. So here's a chart of secant values from 0 to 2 pi. And I'm going to again draw the y-axis and the x-axis through these values. And where secant is undefined, I'm going to draw a vertical asymptote. And then I will connect those values. And this is what the secant function looks like from 0 to 2 pi. Now, the graph of secant x is very similar to the graph of cosecant x, except that there are different locations for the asymptotes. Here, the secant function has asymptotes at pi over 2 and at 3 pi over 2. And notice that when we draw the graphs, we have one full branch between asymptotes at pi over 2 and 3 pi over 2. But on the left side and the right side, we have 2 half branches. Now, typically, we actually prefer to graph with 2 full branches. I'll show you what I mean by that in just a moment. Okay, now let's take a look at some features of the cosecant and the secant graphs. The first thing, and very important to know, is that because cosecant is 1 over sine, we use the sine graph as a guideline for cosecant. Likewise, because the secant is the reciprocal of the cosine, we use the cosine graph to help us find the secant. So let's take a look at this graph. It's either a sine or a cosine. I can't tell which because there's no y-axis. What we're going to do is identify where this graph crosses the x-axis. These are called the zeros. And wherever sine or cosine is 0, its reciprocal, cosecant or secant, has a vertical asymptote. That's why these functions are good guidelines for graphing secant or cosecant. Notice also that the two functions touch each other at the maximum and minimum values. We'll see more of this in just a moment. So let's graph 2 full branches of f of x equals cosecant x. The guideline graph, g of x, is sine x, its reciprocal. And the first thing we're going to do with this is find the sine function. Plot out the 0, maximum, 0, minimum, and back to 0. And then we'll lightly draw in the sine function. This is not the main function, so that's what we want to draw it lightly, usually with a dotted line or something like that. Then we identify where the sine is equal to 0. And where that is, we draw a vertical asymptote. And of course, the vertical asymptote is for the cosecant function. And once we have our asymptotes drawn, we just find 1 at pi over 2, and the sine is 1, and the cosecant is also 1. And when it's at pi over 2 and positive, we get that point, and the graph goes upward from there. And at 3 pi over 2, where it's negative, the graph goes downward. But they do touch at that one point in each branch. Okay, so here is the cosine function. And I mentioned a moment ago that we're trying to get 2 full branches, and here's what I mean by that. When we draw cosine, on the y-axis we start at 1 at the maximum, then we go to 0, then the minimum, then back to 0, then back up to positive 1. And if I were to draw this graph in and recognize where we have 0, we'd recognize that it only happens at pi over 2 and 3 pi over 2. In other words, there are only 2 vertical asymptotes. What we'd like is a third vertical asymptote so that we can get a full branch between the pair of asymptotes. We can either go to the right beyond 2 pi, or we can go to the left at negative pi over 2. Typically, we go to the left, to the negative side, from negative pi over 2 to positive 3 pi over 2 for our values for drawing the secant function. Here we're asked to draw two full branches of secant x. We'll start by identifying the guideline graph g of x, which is cosine x. Let's go ahead and plot the points. 1, 0, -1, 0, and back to 1. But what we're going to do is also draw on the left side over to -pi/2. That'll give us a third 0 and allows us to then have 3 vertical asymptotes. Once we have the asymptotes drawn in, we connect the graph at +1 or at -1. And in the first pair of asymptotes, it's 1 and the graph goes upward. In the second pair of asymptotes at pi, the graph starts at -1 and goes downward. And that's the graph of the secant function. Well, sometimes we modify the secant function, the cosecant. We don't just do secant and cosecant only. Just like sine and cosine, we might have a times cosine bx. Well, here we have a times secant bx. Same thing for cosecant. Now, if a is a negative number, then the guideline graph is reflected, but so is its corresponding f of x graph. And no matter the value of a, the graph of f of x and the graph of its reciprocal meet at the maxima and minima points of the guideline graph, g of x. So here's an example where we're asked to graph two full branches of f of x equals 2 times secant of 6x. First, let's identify the guideline graph. This is 2 times a cosine of 6x. You see, they're almost identical. The amplitude is 2. It's positive, so it's not reflected. The frequency is 6, and the period is 2 pi over 6, which of course simplifies to pi over 3. So we'll come out a certain distance on the x-axis and identify the period pi over 3. Then halfway is 1/2 of pi over 3 is pi over 6. 1/2 again of pi over 6 is pi over 12. And then the 3/4 period is 3 times that pi over 12, which is pi over 4. So now we have all of the x values that we need. Let's also mark the y-axis with the amplitude at 2 and also at -2. And because the guideline graph is a cosine function, it starts at the amplitude on the y-axis at 2, and then 0, -2, 0, and +2. And then we'll draw in lightly the cosine graph. Wherever cosine is 0, that's where we have the vertical asymptotes. We need one more vertical asymptote, so we'll go to the left over to -pi over 12, and we'll draw in its asymptote. And now that we have 3 asymptotes, we can draw 2 full branches between each pair. And even though it has an amplitude of 2, the graph of secant and cosine still meet. And the same is true at -2. Okay, let's look at this example. Graph 2 full branches of f of x equals -4 cosecant of 5/3 x. The guideline graph is -4 sine of 5/3 x. The amplitude is 4, and because it's negative, it's reflected, yes. The frequency is 5/3, and the period is 2 pi divided by 5/3. We can rewrite that as 2 pi over 1 times 3/5, and that becomes 6 pi over 5. So that's the period of our sine function. We'll locate that on the x-axis, 6 pi over 5. We'll find the halfway mark between 0 and 6 pi over 5, which is at 3 pi over 5. And half of that, for the quarter period, is 1/2 times 3 pi over 5 equals 3 pi over 10. That's the quarter period. And the 3/4 period is 3 times that value, 9 pi over 10. We have to mark up the y-axis, an amplitude of 4, 4 on the positive y-axis, -4 on the negative y-axis. And then we plot points for our guideline graph. And because it's reflected, we start at 0, but we go to -1, then to 0, then +1, then back to 0. And we draw in the graph. What we're looking for, though, are the zeros of the sine function, because that gives us the asymptotes of cosecant. And the graphs touch at the maxima and minima. So at 3 pi over 10, at -4, we have a maximum for the cosecant function, and it graphs downward. And at 9 pi over 10, they touch at +4, and we have the minimum for a graph that goes upward. Well, I hope this has been helpful to you, and be sure to check out my other videos. And have a good day.